Hello everyone, welcome to the Organic Pharmaceutical Chemistry Laboratory. Today we are going to do and synthesize a compound called butyl iodide, or as it's known, 2-iodobutane, which is the iubic name of this molecule. So as you can see here in this picture, we do have the 3D structure of the compound. So we have the white balls right here, okay? They represent the hydrogen atoms. And we have this chain, the black one, which is the chain of the compound, which has like 4 carbon. And we do have the purple color, or the ball right here. Let me just highlight it, which is the iodine. This picture represents the look of the final product, which is the butyl iodide. So it's impure. We are not going to purify it. We will just like make the compound, collect it, and that's it. And then we will be finding out the percentage yield of the molecule. This is also the 3D structure of the molecules, as you can see here. Oh, let's get started. So there is like a term called organic iodines. So organic iodines, they are organic compounds with iodine atoms attached to it. So they are broken down into 2 types. The first one is called the aliphatic iodines, okay, or iodides, and the second one is aromatic iodides. So they are different, and in our synthesis we are going to deal with only aliphatic iodides, which is n-Butyl iodide, okay. And organic iodides in general, they are very useful reagent as they have lower heat of formation than chlorine and bromine analogs. So if we do a comparison between a molecule that consists of chlorine or contains chlorine and bromine, and compare that with iodine, would be like a significant difference. And for the aliphatic iodides, they are used as alkylating agent in synthetic organic chemistry. Okay, this is really important. So now let's explore more and talk about some compounds of iodine. The first one is called iodoform. So it's well-known molecule, all right, and it has like several pharmaceutical applications, and we are going to talk about some of them and see like how we can apply them in the pharmaceutical field. Now, iodoform is also used for root canal treatment. Okay, this is the first one, and it's also one of the components of some root canal filling in paste. All right. The second point, iodoform acts slightly as anesthetic and as a hemostatic, and it does not irritate the periapical tissue. Iodoform itself does not have antiseptic properties, only in contact with the tissues. So this is how it looks like. So endodontics and its temporary filling of root canals. This is the one of the or the iodoform that is used in the dentistry. Okay, this is the first one. All right, and it's also for the restoration of teeth and temporary filling. Now let's move and talk about another compounds of iodide, which is bovidone iodine, or as it is called or known as PVP1. I don't know, guys, if you may have like heard of this medication, but it's also known as iodopovidine. This is the alternative name of this medication. It's an antiseptic used for skin disinfection before and after surgery. So some people, when they went through a surgery, they want to like do not get infected by any kind of disease or viruses, so they use iodopovidine as one of the medications in order to avoid getting any bacteria or getting any viruses to their incision. It's also used like as a disinfect the hands of healthcare provides and the skin of the person they are caring for. Uh, Likewise, it's used for minor wounds. Okay, it could be applied as a liquid or as a powder, depending on the type of the or the manufacturing the medication and how it's manufactured. Okay, so let me show you how it looks like. This is it. So it costs only like $16, so it's cheap, and it's like bovidine iodine swab sticks as it's shown right here. It's antiseptic and it's used for only external. So it's an external use, okay? It's for external use, all right? So this is how it looks like when you want to apply on the skin. It could be for like minor wound or injuries, or it could be like after or before surgery, as we mentioned previously. Now, n-Butyl iodide is also used, as we mentioned in the previous slides, uh, in the medicinal industrial applications, in human and animal nutrition products such as antiseptics, pharmaceutical intermediates, polarization films for liquid crystal display LCD, chemicals, and then also derivatives are also used as organic building blocks, analytical reagent, etc. This is some like general uses of n-Butyl iodide. Now let's just talk about the physical properties of n-Butyl iodide. So you don't have to memorize these three, okay? You just only need to know like the compound that you are in touch with, okay? So the boiling point of this molecule is 129 to 131 Celsius, and the molecular formula of the compound is C4H9I, okay? And the molecular weight of it is 184.02 mole per liter. So this molecule, as many molecules, has an alternative or alternative names. Okay, so you can find as 1-iodobutene, okay, or 1-butyl iodide, or butane 1-iodo. So as we've like mentioned previously, especially in the first slide, that the 3D structure of the molecules is shown right here. Okay, this is it, the hydrogen and the chain, and we have the iodine right there. And this is on the right side is the 2D structure of the butyl iodide, and we have carbon right here, and carbon, okay, with 3 or 2 hydrogens, and we have the iodine right there. So n-Butyl iodine can undergo a nucleophilic substitution when it interacts with sodium cyanide, as it's shown below. So let me show you how this mechanism is done. So first of all, we have the n-Butyl iodide, okay, this is it, okay, on the left, and we have the CN, the cyanide or sodium cyanide. So the bond between sodium and cyanide is an ionic bond. So it's negative and positive partials. So the pair of electrons on the carbon of the cyanide right here, okay, right here, would attack the carbon of the iodine, and at the same time the iodine will go away and it will take it or kick it out in order to form a molecule as it is shown right here on the right side, okay? And the iodine that was resulted as this reaction, as the substitution reaction, will like attach or bind to the sodium to form sodium iodine, which is a salt. So this is the result, the major and the byproducts of the interaction between the sodium cyanide and n-Butyl iodide. Okay, this is really important. You got to like understand how the mechanism takes place. Now we have some characteristics of organic iodine. So they are very useful reagents as they have lower heat of formation than chlorine and bromine, as we mentioned before. And aliphatic iodines are used as alkynic agent in synthetic organic chemistry. Number 3, iodine organic compounds are useful in dye industry, so they use for like dye stuff, all right, and for the high bright colors, as well as pharmaceutical industry. So it's really important in the pharmaceutical field, all right. They are really important for the reduction of X-ray contrast media, okay, and for the formulating antiseptics. Here are 4 different compounds of iodine, and we've talked about the iodoform, okay, it's the first one. And we've talked about the iodoacetic acid, which is one of the molecules. So iodoacetic acid is used as in the biochemical research. It alkylates free thiol groups, but not disulfide bridges. So this is really like an important use of iodoacetic acid. Okay. The next one is methyl iodide. Okay, methyl iodide is also called iodomethane. This is the one of the alternative names of methyl iodide. It's used in microscopy and in the testing for pyridine. It's irritating to skin and mucous membranes. Okay, or mucous membranes. Okay. Number 4, ethylene diamine dihydroiodide. This is the one of the molecules or compounds of iodine, or derivatives of iodine. It's used in animal feeds to prevent deficiency of iodine.